How to design and build a garden deck. Timber or composite decking. What structure to use. Do I need foundations? Fixings for the decking. Which way up for the decking? What tools to use? And what about costs? How to list and order materials, control your budget. I'll explain everything here and review the latest products to help you choose the pros and cons and my personal recommendations at the end. Now let's start with the design, the layout of the deck. I'm going to transform this tired looking rear patio area as part of this 1930s house renovation project. I've just demolished a hole to create this new sliding screen where before there was just a window. Now I want to open up the garden like this. First I'll take dimensions of the area I want my deck to occupy, length, width and height off the ground. I'll use a little digital laser measure, really handy for this kind of thing when you're working alone. You can see my review of it here, and I'll take the overall dimensions like this. Now I'm sketching on the supporting joists and where I can put supports in. So here's the maximum span, and that gives me my lines of support. The main structure first. I'll always do this in timber. There are plastic composite options such as this, and there's aluminium as well. These are supplied by the decking manufacturers to make a complete system. So why do I always choose timber? Kiln dried and graded timber or lumber, even without any additional treatment, will last a lifetime outside, provided you prepare it the way I'm going to show you. It's far easier to deal with in that it's locally available, easy to cut, and comes in the lengths you'll need. And then there's the cost. Composite structural joists are just really expensive in comparison to timber, but we'll get to costs in a minute. So I'm using timber for my supporting frame. I'll only use plastic if I'm so limited in height that I have to have the frame laying on the ground, like here for example. And from my plan to get our spans, we should try to choose a shorter direction for which way we run our joists. The idea is to get that perfect relationship between depth and span capability. How many lines of intermediate supports will determine the depth of the joists, and I'll work out my timber sizes by first looking at the dimensions. And before we finalize this, I want to establish the gradient of the ground, since I need the underside of my timber substructure to be a minimum of 50 millimeters above the highest point. And why would that be? Well, to make that kiln dried frame last, I need it to be ventilated so that moisture in and around it can evaporate off it. Back to the gradient, I've used all sorts of levels in the past, staffs and theodolites. Nowadays you can use these inexpensive laser levels which come with their own staffs. You just fix the leveling laser to a fixed point, we call it a datum, and we go along the area with the staff. Start moving the receiver up or down the pole, and when it beeps, it's at the same level as the datum, and you can make a note of it on your plan. If you don't have a digital level, use the old school method. Take something that you know to be level. In this case, I'll use the eaves of the house, but it could be a garden wall, for example, and just measure along it and you'll figure out the fall. With my highest point established, levels marked, joists sketched on, then using these structural tables, I'll work out the optimal size. And I know from experience of these kind of span lengths that I'm going to choose between 145mm C16s and 95mm C16s. For decking, I'll always go for 400 or 450 centres and never 600, since I prefer to use as small a substructure as possible. The bigger the gap between the joists, the centres as we call them, the stronger these joists need to be. Plus, I don't want to get excessive bounce in my decking. The centre should always need to be a divisor of the length of the decking board you're going to choose, and we'll get to the decking in a minute. Before the decking and before we attach our joists, we need to consider how we're going to support our timber substructure off the ground. And if you're building on natural ground, such as a grass area, then you'll need to use a post hole digger with this grafter shovel and create some holes for some concrete pads. I'll aim for a minimum of 450mm. I've seen people do it a lot shallower. Why scrimp on an extra 20 minutes per hole of exercise and graft? This is the one chance you get at it before the deck is on. Enjoy it and do it right. You can get Postcrete, which is a ready mix solution where you just add water and pour the bag in, like I'm doing here for these posts. But for a floor of this size and height off the ground with a live load such as people and some heavy patio furniture, I'll be using a stronger mix. So I would be hand mixing concrete either in a barrow or mixer if you have one, like this electric mixer, and I'll get pre-mixed bags of 25 kilograms of ballast and 25 kilogram bag of cement, adding a bit of water, and that will take care of my holes. I'll just paint a piece of graded timber in bitumen and pour the concrete around it, then level it in both directions. You can also use threaded rods if you want to go belt and braces. I'm doing that for this example, but it's probably overkill for a deck. There's other solutions like these bracket fixtures that you just build off the concrete pads you've just poured, but they don't allow for much flexibility on sloping sites. For grass and soil areas, I'd stay away from the surface block solutions. That's just too great an opportunity for movement. I think you should just do it right and dig the holes. For this one, I've got this concrete patio base, so I'm going to use these plastic adjustable decking supports by this company here. I'll leave a link below in the description. The advantage of this system is that it's adjustable and the little spacers can be orientated to take account of my sloping garden. You just add the additional spaces as required and you use the masonry fixings into the concrete base. Just drill a pilot hole and secure some screws into the concrete with your impact driver. Because there's just compression forces at play, this is the right time to use these simple self-tap masonry fixings. But don't ever use them where there is some tension forces as well. For example, if you are fixing something to a wall that's going to hold up a floor. We'll get to that later, but back to the joists. The substructure for a garden deck of this size, I like to make a SketchUp model to help me with my quantifying and ordering, and you'll be surprised at just how easy SketchUp is once you know the few command tools to use, and it helps enormously with both the design and the specification of the logistics. Here's my frame, here's my quantity of C16 pressure treated timber in linear meters pulled from my model, and here it is pasted into my costing spreadsheets. And if you want a copy of this spreadsheet for you to adjust for your own projects, you can download it here from my website. There's a link in the description. Just give me a like for the vid if it helps you, and you'll help me. I've included options for concrete footings, postcrete footings, fixings and plastic support fittings depending on your circumstances. Back to my design of the deck, and I need to choose my decking material and my fixings. We've got to choose between composite decking and timber. And some of the composite decking products I really like, especially this stuff from Ecoscape. Not the cheapest, you can get this stuff for a bit less and it's fine. But I really like the texture and colours that Ecoscape get. I think you get your money's worth in comparison to the cheaper ones, and their product guides and fitting system is pretty good. But 3 things for me to consider. First is cost per square metre, which works out about this once you include the fixings and extras, which they sometimes forget to mention on their website, versus this for timber decking. Over a big area like this, the thing about plastics is thermal movement. A garden deck gets a load of sun for some of the day and then it's in the shade for the rest, so there's a lot of temperature differential. Plastics, even those with a timber composite such as this, don't love that, and the way the manufacturers get around this is by making larger joints, 5 to 6 millimeter minimum. You get a mechanical fixing system that makes your joints for you using these spacers, and which also means you can fix to their plastic subframes or a timber frame. Personally, I don't love such a big joint over such a large area. It means more dust will accumulate within the void over the years, which then attracts all sorts of organic things that can result in you having to get in there somehow and clean it out after a period. I can get away with significantly less space between the boards with timber, and if I spend a couple of hours each spring maintaining it, it will last as long as the composite. I'll go into that another day. My final reason for preferring timber, in the end, I just prefer the way it looks, and that is an organic and sustainable material, especially this European redwood, which will be stocked at your local timber merchants. You'll also have the nationwide stockits. I'll leave a link to a few in the description, along with all the other product links you could consider for this type of project. In the next video, how I built this deck, whether you should place your grooves facing up or down, how to protect your timber structure, and spoiler, don't use tape my own final cost and what I would do differently. Please hit me a thumbs up, it really helped, and thanks for staying till the end.